All right, hi guys. Welcome to 3-2 linear functions. So what today is it's going to be familiar things you've seen, but we're just going to step it up and look at things in function notation, okay? So function notation is very similar. So it is slope-intercept form, so y equals mx plus b, but instead of using y, we're going to use a more advanced way of writing it by using what we call function notation f of x. And you pronounce it like they say f of x, okay? So, obviously when you graph something, you can always create a table, and then for us, we're used to saying x and y table values, but now we're going to say x and f of x table values. And the table's going to show your domain. Your domain is your x values, and your range is your y values. Okay, domain and range are just fancy names for x values and y values. And then, of course, we're going to graph some more, and just graphing in function notation instead of y equals. But it's going to be the same approach. So first of all, let's just get comfortable in function notation. So in this question, they're saying, what is the value of g of x, 5x plus 1, when x is 3? So what that means is take 3 and plug it in for x. So when doing function notation, the more advanced way of writing this, by the way, this is g of x. In the above slide, we used f of x. You could use h of x. You could use any letter in front of x. Typically, we use f of x, but we can use any letter. They're using g. So when you go ahead and start plugging a number in, so I'm going to plug in 3, function notation is nice because I actually write g of 3 equals 5 times 3 plus 1. Then I'm going to simplify, so that's 15 plus 1, and that's a 16. So the way you read this is g of 3 equals 16, and what that tells me is when you plug in 3 into this equation, you're going to get 16 as your output, your range. So let's try it again, okay? So evaluate each function for when x is 4. So I'm going to say, okay, so when I plug in 4 for x, so g of 4 equals negative 2 times 4 minus 3. Now I'm just going to simplify. So negative 8 minus 3, so that's a negative 11. So g of 4 is negative 11. When I plug in 4, I get negative 11. Why don't you try the right-hand side and push play to check your work? Okay, so we're going to plug in 4. So h of 4 equals 7 times 4 plus 15. Okay, so that's going to be a 28 plus 15. And let me see, I'm going to stack so I can do my addition. 13, carry the 1, so that would be a 43. So h of 4 is 43. Okay. So this next slide is still asking the same thing. It's just having you plug in 2 different numbers, okay? So basically, you're just doing the work twice. So first, I'm going to find f of 2. So that means I'm just plugging in a 2. Showing your work is very important. So 8 minus 3, that's a 5. And of course, writing it in function notation is the big goal of this lesson. So do make sure you do f of 2 or h of 2 or whatever they're prompting. So now let's plug in a 6. F of 6 equals 4 times 6 minus 3. Okay, so that's a 24 minus 3. So that would be a 21. So f of 6 is 21. Okay, why don't you push pause and do this one on your own and push play when you're ready. Be careful with your order of operations. Okay, f of 2 is a negative 2 minus 2. So that would be negative, okay, 2 minus 2, that's a 0. Ooh, I love a 0. Negative 0 is just simply 0. So f of 2 is 0. When I plug in 2 for x, I get 0 for the y value. Now let's plug in 6. So negative 6 minus 2. So function notation is also nice because you can follow your work, which is very nice. Anyone can follow your work. It's communicating. Okay, so then this would be 6 minus 2 is a 4. No need for parentheses. So f of 6 is a negative 4. Not so bad. You're simply just substituting and using function notation to express your answer. All right, now what we're going to look at is our tables. And looking at the tables, we're going to take those tables and write them into function notation rules. A rule is an equation. So simply, they want us to look at this table below and write an equation, which is mx plus b. So we're going to put an equation in slope-intercept form. Okay, so they're saying the cost to make 4 bracelets, 1, 2, 3, 4, is shown in the table below. How can you determine the cost to make any number of bracelets? So that's a generic question, and it's saying, what's the equation for this setup? Okay, guys, so when you're looking at a table, well, first of all, what I would like to do is take this table and put it on a coordinate plane, okay? I want to graph this because you guys are good graphers at this point. And let's go ahead and see what it looks like and analyze that, and then we'll look at a more precise way of doing this. But I just want to get our feelers out on graphing this first, okay? 2, 3, 4. So my x-axis I'm going by 1s, my y-axis I'm going by 2.5. But notice I only labeled every other line just to keep it a little cleaner. All right, so at 1 I'm at 17, so that would be just a little under 17.5. At 2 I'm at 32, which would be a little under 32.5. At 3 I'm at 47, which is a little under 47.5. Okay, and then 4 goes off the screen. It'd be somewhere up in here, and I'm not going to approximate that. So now I'm going to take a straight edge, and I'm going to make a line. And let's see. Okay, it's actually really hard to make a line on my iPad, so I'm doing the best I can here. Let's see. All right, so I have my line. Now, I'm looking for always my slope and my y-intercept, okay? My y-intercept looks to be somewhere around 2.5, you know, and so I'm going to put an approximation here, okay? It's somewhere around 2.5, but I can't be quite sure. I mean, I did graph this by hand, and I went by 2.5, so I'm, you know, I'm forced to approximate a little bit. And then my slope, if you're looking at, if you go from, I'm going to change my color here. If you go from one point to the next, so it's going from 17 to 32. So that's up 15 over 1. So my slope is a 15. Okay. Now you can see that as they're saying here, these are your x values, these are your y values. Your constant rate of change is your slope. That is your slope, okay? So the change in your y values is what dictates your slope. So I can see it's increasing by 15, so my slope's 15. Now to find my y-intercept, to get the exact, 2.5 is approximate, I want the exact. Now remember guys, with y-intercepts, it's always where x is 0 on the graph, or it's a coordinate pair. So I'm looking here, that's where I'd approximate, but what if I just completed the pattern on the table? So I can see on the x values it's going by 1s, so I'm going to put a 0 in there. So if it's increasing by 15 to go backwards, I would have to decrease by 15, which would make this a 2. So my actual y-intercept is 2. I was close with 2.5, but close isn't good when writing equations. We want exact. So my final answer would be f of x, because I'm doing function notation, equals 15x plus 2. Okay, so some things that are important here, guys. When you are looking at a table to write an equation, you need to make sure your x values are increasing by 1, okay? They need to be in order, consecutive. And then the y values are going to increase by whatever the rate is, but it will be constant, okay? So the change in the y values shouldn't be different. It should be a constant number. So let's go ahead and look at our next example. We won't graph it. We're just going to simply look at the table. So the very first step is make sure your x values is increasing by 1. That's critical, okay? Then look at the change in your y's. So it looks like it's increasing by 6.5. And yes, check every data point they give you just to make sure all of it's increasing. These should all be the same. Since these are linear functions, the rate shouldn't change, nor should your x value, the space between your x values. So let's see, my slope then is 6.5, because that's how much my y values are changing. My y-intercept is when x is 0. So I'm just making another space on the table for where I have an x value of 0. And so I'm just going to continue the pattern. If it's increasing by 6.5 to go backwards, you would decrease by 6.5, which would make that a 0. So my y-intercept is 0. So we would say f of x equals 6.5x plus 0. Now, of course, guys, you know you don't need to say plus 0 at this point. You would just say equals 6.5x. So why don't you pause it and do B and push play when you're ready. Okay, so for B, make sure you're increasing by 1s on the x value. That's important. And then go ahead and find your rate on the y values. So I'm increasing by 3 in the y's. So my slope, my rate is 3. And my y-intercept, I need to see where x is 0. So I'm making a spot for 0 on the table. So that means to go backwards, 1 minus 3 would be a -2. So my y-intercept is a -2. Y equals 3x minus 2. Oops, and they want function notation, so f of x equals 3x minus 2. It's such a default to write y equals, but when they want function notation, definitely give it to them in that. Okay, use the table to determine whether the function could represent a linear function. So not everything's going to be a linear function. You do need to make sure it has the same constant rate. And before you do that, you need to make sure your x values are increasing by 1. So they're not here. So what we're going to do is kind of complete the table just to make sure it does have a consistent pattern. So in between here is a 1. So 0, 1, 2, 3, oh, and now they're skipping the number 4. So I'm also going to put a 4 here. So 2 and 3 were the only two consecutive numbers they gave me. So this is where I can see the rate that it might be. So in between 8 and 12 is a 4. So let's see if this constant rate of 4 holds true for all the numbers. So 12 plus 4 would be a 16. 16 plus 4 is a 20. Oh, okay, so that works. Let's make sure it works also going backwards. Every number on the table needs to satisfy this pattern. So 8 minus 4 is a 4, and then 4 minus 4 is 0. Yay, so this definitely does represent a linear function. Again, guys, if your y values are different, then, so for example, if your rate was changing, your x's are going by 1s, but your rate on the y values are changing, then it would not be a linear function. So not everything is a linear function. In this case, it is. So my slope is 4, and they gave me my y-intercept, which would be a 0. So we would say f of x equals 4x, and I don't need to state plus 0. So there's my function. Okay. Use the table to determine whether this could be a function or not. So make sure your x values are going by 1, -1, 0, 1, 2. Okay, check. I like the top. So let's see what's happening on the bottom. Okay, 2 to 2 to 2. So what's happening is I'm increasing by 0. So my slope here is a 0. My y-intercept is a 2. So remember, slope, dude, when your slope is 0, that's horizontal, okay? That's when you would have just a y equals equation. So there's several ways to approach this. You could first say, you could write it just as f of x equals 0x plus 2. Then, of course, you don't need to state 0x, because 0 times anything goes away, so it would be f of x equals 2. Another way you could see it is that your y values, or your f of x values, is consistently a 2. So that is constant. So you would just state f of x is 2. That's the shortcut. All right, and then the last bit to this is just graphing, and this is graphing just like you did in all the other chapters all throughout the year and last year. So it's the same deal. Your slope, which in this case is -1, and your y-intercept is 1. So now we're just seeing it in function notation, but nothing else changes. So my y-intercept's 1, so you plot a coordinate pair as 0, 1. And then my slope is -1 over 1. And you make your line. And that's it. Don't overcomplicate these. So I'm going to stop here, but I do suggest you complete the notes and graph them, and then you can scroll and you can check them with the answer key given. Thank you for tuning in, and I hope you have a wonderful week, and I'll see you soon.